Okay, so students, please look at this presentation. We have seen in our previous classes simple stress and strain, Young's modulus of elasticity, and we have seen modulus of rigidity, ratio of shear stress to shear strain. We have seen bulk modulus of elasticity, compatibility equation, and equation of equilibrium you have studied in your engineering mechanics. So today we will try to deal with few numericals related to the relationship between modulus of elasticity, bulk modulus of elasticity, and modulus of rigidity.
Rigidity.
So here you just watch this. E equals to 9gk upon g plus 3k. So in this equation you will find that all three moduli are there. Clear to all of you? If you will look at this equation, E equal to 3k 1 minus 2 mu. So there are three parameters. One is Poisson's ratio. We have discussed in my last class. Poisson's ratio is a ratio of strengths lateral to linear strengths. So Poisson's ratio is also a unitless parameter. So if you know either modulus of elasticity and Poisson's ratio, you can calculate bulk modulus of elasticity. If you know modulus of elasticity and bulk modulus of elasticity, you can calculate Poisson's ratio. Means in short, you have three unknowns with you. First one is E, first one is E, second one is K, that is bulk modulus of elasticity, and third one is Poisson's ratio. So it is very easy to calculate any one value out of these three unknowns. So if you consider this E equal to 3k 1 minus 2 mu, E equals to 3k 1 minus 2 times mu, right? So what will be the units of these modulus? You know, the units of these modulus are same as that of stresses. If a rod is subjected to an axial pull and modulus of elasticity is suppose 2.5 into 10 to the power 5 megapascal, and Poisson's ratio suppose 0.25. I am assuming the values. So it's very easy for you to calculate the bulk modulus of elasticity. So the bulk modulus of elasticity K will be equal to E upon 3 times 1 minus 2 mu. So please calculate and tell me the value. You substitute E equal to 2.5 into 10 to the power megapascal. Poisson's ratio 0.25. So what value you will get? for bulk modulus of elasticity? Please tell me. Obviously, this value will also be in megapascal. Can anyone tell me? Can you please solve and tell me the value? Anyone?
Wait, sir.
Yes. It's very easy, students. One minus 2 mu. 2 mu is 0.25. So 1 minus 2 into 0.25. So this value is coming 0.5. 0.5 into 3. Take inverse of that and multiply it by value of E. So what is the value you are getting? Can anyone tell me?
Sir, 1.6 into 10 to the power 5, sir.
Okay. Means
In
166.67
6 will be repeating, sir.
into 10 to the power 3 megapascal.
Yes, sir.
Now, megapascal. In mechanics of solid or strength of materials or introduction to solid mechanics, you have to remember one thing. Megapascal. 1 megapascal is 1 Newton per millimeter square. And 1 Pascal, please remember, 1 Pascal is 1 Newton per meter square.
Yes, sir.
So in this way, if you know the relationship between modulus of elasticity and bulk modulus of elasticity, you can calculate any one parameter out of 3 parameters. Right? One more variation I shall discuss here. If you know the value of E and K, right, you can easily calculate the value of Poisson's ratio. Nothing. Now, let us see the relationship between the modulus of elasticity and modulus of rigidity. 9 gk upon g plus 3k. Right. So, one more relation, you see, Young's modulus of elasticity E is equal to 9 gk. So, we have already discussed that how the modulus of rigidity, right, if you will look at this, we have already discussed modulus of rigidity, shear stress upon shear strain. So, E equals to 9 gk, g plus 3k. So this is the simple relationship between all 3 moduli, E, G and K. So the benefit of this is if you know any 2 moduli, you can easily calculate the third one. It's so easy.
Yes, sir.
If a body is subjected to a load, right, and having some particular area, and it is observed that, and you know very well that the unit of moduli is same as stresses. So if you know that the modulus of elasticity, if I am taking the same value here, suppose 2.5 into 10 to the power 5, and I'm taking k value, that is bulk modulus of elasticity, suppose as 1.1 into 10 to the power 4. The units followed are, suppose, megapascal. Then you please calculate the value of modulus of rigidity. Obviously, that value will also be in megapascal. So can you please calculate now? One point one into 10 to the power 4 into 3. You will get something. All students, please try. You will get 2.5 into 10 to the power 5 equals to 9 times g. K value is 1.1 into 10 to the power 4 divided by g plus 33,000. This you will get. If you will further simplify, you will get 2.5 into 10 to the power 5 g plus 8.25 into 10 to the power 9, which will be equal to 9.9 into 10 to the power 4. So finally 9.9 into 10 to the power 4 minus 8.25 into 10 to the power 9 divided by 2.5 into 10 to the power 5. So what value you are getting? Please let me know. Is it something 32.99? Are you getting the same value into 10 to the power 3? Are you getting the same value or different value? Yes, what value you are getting? This much time is not required. You simply multiply this in this denominator, 2.5 into 10 to the power 5 g plus 3 into 1.1 into 10 to the power 4 into 2.5 into 10 to the power 5 equal to 9 gk. So I think anyway you just write it's 32.99 into 10 to the power 3 megapascal, plus or minus indicates the change. You have to consider the magnitude only. So you have two relationships in hand which correlates all the moduli, and this is possible because of the constant Poisson's ratio. If you know any one value you can easily calculate the other one. I hope it's clear to all of you the relationship between all moduli of elasticity and how to calculate any parameter, either Poisson's ratio or any modulus of elasticity out of 3. Okay students, we shall discuss in my next class the temperature stresses. Thank you
Sir,
very much.
sir, my